Hello, I'm Sabrina from Huawei Developers and welcome to Huawei tutorial series. I'm going to explain the Safety Detect. In this video, I will explain what Safety Detect is, and then we will examine the development process. In this tutorial series, we will learn about SysIntegrity API, AppsCheck API, URLCheck API, UserDetect API, WiFiDetect API. What is Safety Detect? Safety Detect protects you from security threats by using powerful security features in your application. SysIntegrity API checks whether the device running your app is secure, for example, whether it is rooted or not. AppsCheck API obtains a list of malicious apps. URLCheck API determines the threat type of a specific URL. UserDetect API checks whether your app is interacting with a fake user. WiFiDetect API checks whether the Wi-Fi to be connected is secure. For the integration of this service, we will need JDK version 1.7 or later, Android Studio version 3.6.1 or later. In the second step, we need to register as a developer, create an app, generate and configure a signing certificate fingerprint. You also need to add the AG Connect Service JSON file to your app. To download the AG Connect Services JSON file, go to Project Settings and click General Information. In the App Information area, you can download the file. Then, copy the AG Connect Services JSON file to the app directory of your Android Studio project. The next step is adding Nearby Service dependency in the Dependencies block. You can find the latest version on the Huawei Developer official website. First, open the build Gradle file in the app directory. Add build dependencies in the Dependencies block. And before building the APK, configure the obfuscation configuration file to prevent the HMS Core SDK from being obfuscated. We are now ready to start the development. SysIntegrity checks the system integrity of a device. If the device is insecure, the app will take appropriate measures. The service's features are TEE-based system integrity check results. The API evaluates the system integrity in the secure boot process in the trusted execution environment and will dynamically evaluate the system integrity. The check results are highly reliable. Trustworthy system integrity check results. System integrity check results request the certificate signature. The server uses the X509 digital certificate to sign the system integrity check results and transfers the signed JWS format results to the SysIntegrity API. The signed results cannot be tampered with. To call the SysIntegrity API, perform the following steps. 1. When calling the SysIntegrity API of Safety Detect, you must pass a nonce value that will be contained in the check result. You can check the nonce value to verify that the returned result corresponds to your request and does not encounter replay attacks. A nonce value must contain 16 to 66 bytes. Otherwise, the API call may fail. 2. Safety Detect provides two SysIntegrity APIs which require different parameters. However, both the nonce and app ID parameters are required for the two APIs. As for the SysIntegrity API, you also need to pass the signature verification mode to SysIntegrity request. The signature verification mode is the same as the specified by ALK and header of the obtained JWS format response. Sign into App Gallery Connect and click My Projects. Find your app project and click the desired app name. Go to Project Settings, General Information, and view the app ID in the App Information area. HMS Core APK sends the check result to the Huawei server to verify the certificate and returns the result to you through the SysIntegrity RESP object. You can use the getResult method of the object to obtain the response in JSON Web Signature JWS format. Parse the JWS format result to obtain header, payload, and signature. Obtain the certificate chain from header and use the Huawei CBG root CA certificate to verify it. Verify the domain name of the leaf certificate in the certificate chain. The correct domain name is sysintegrity.platform.highcloud.com. Obtain the signature from the signature and verify it. Obtain the integrity verification result from the payload. Provides risk assessments of your app's behaviors with list of malicious apps. Also, it has two main features. The accuracy of malicious app checks reaches 99% according to authority. Unknown threats can be detected based on behavior. You can directly call Get Malicious Apps list of Safety Detect client to obtain a list of malicious apps. Use rasp.getMaliciousApps to get the malicious apps data. If Get Malicious Apps was successful, use Get APK package name to get APK name of malicious app. Use Get APK SHA-256 to get APK SHA-256 of malicious app. Finally, use Get APK category to get the category of the malicious app. Categories are defined in AppsCheck constants. When a user visits a URL, this API checks whether the URL is a malicious one. If so, you can evaluate the risk and either warn the user of the risk or block the URL. Before using the URLCheck API, you must call the init URLCheck method to initialize the API. The sample code is as follows. Specify the types of concerned threats as the input parameter of URLCheck API. Constants in the URLCheck threat class contain the supported threat types. If your app does not need to call the URLCheck API anymore, or will not need to do so for a while, you can call the shutdown URLCheck method to close the URLCheck session and release relevant resources. URLs of malware type are marked as URLs of pages containing potentially malicious apps, such as homepage tampering URLs, Trojan-infected URLs, and malicious app download URLs. URLs of phishing type are marked as phishing and spoofing URLs. Fake users can be identified based on the real-time risk analysis engine. The API collects related data in the authorized scope and uploads it to the real-time risk analysis engine to check whether the current user is a fake one. Outside the Chinese mainland, users can be verified based on verification codes. If a user is suspicious or risky, a verification code is sent to the user for secondary verification. In the Chinese mainland, users cannot be verified based on verification codes. The No Captcha API on the cloud is used to obtain the user detection result. The UserDetect API provides the behavior detection capability. To use the capability, you can call the init UserDetect API to initialize fake user detection. The sample code is as follows. Call the user detection method of the UserDetect API to initiate a fake user detection request. The API will return a response token object. To initiate a detection request, you need to call the user detection method. Generally, this method is triggered when a user touches a UI control, such as a button. To call the user detection method, perform the following steps. Pass the applied app ID as the input parameter of the method. Add the onSuccess listener and onFailure listener instances as listeners. Override onSuccess and onFailure to process the results. Call an onCloud API, No Captcha in the Chinese mainland, and verify outside the Chinese mainland, based on the response token obtained in the upper point, to obtain the user detection result. To obtain the detection result, perform the following steps on the server. Obtain an access token. For details, please refer to OAuth 2.0 based authentication. Call the Cloud API to obtain the detection result. For details, please refer to obtaining fake user detection results outside the Chinese mainland. The following is a request example. Call the shutdown UserDetect API to disable UserDetect and release resources. After you integrate WiFiDetect into your app can detect ARP attacks, man-in-the-middle attacks, DNS hijacking attacks, and other attacks on the Wi-Fi to be connected. If attacks are detected, your app can interrupt the operation or ask users to confirm whether to continue the operation. This was it for this training video. Thank you for watching, and we hope to see you in other training sessions.